According to the ACT website, there are 5 different kinds of math that could be on the exam. So here are 5 example problems, one for each of those types of math so that you'll be ready for the exam. So here's the first example that we'll be doing in this video. It says, what is 3/4 to the power of -2? So remember that an exponent is basically just multiplying the same thing over and over. So for example, if we had 2 to the power of 3, that's the same thing as 2 times 2 times 2, which is 8. But for this, that seems kind of weird because, like, how do we multiply something -2 times? That doesn't really make sense. Well, let me show you how to do negative exponents. So basically, we're just going to ignore the negative sign for now, and we're going to treat this as 3/4 to the power of 2. So that means we need to multiply 3/4 by itself twice. So we're going to have 3/4 times 3/4. Now remember that to multiply fractions, we need to multiply the tops and multiply the bottoms. So in this case, 3 times 3 is 9, and 4 times 4 is 16. So that means that 3/4 to the power of 2 is 9/16. Now, what does this negative sign do to this? Well, basically, a negative exponent flips the fraction around. So because this is a negative exponent, our 9/16 is going to turn into 16/9. And let's say, for example, you had just a number that wasn't a fraction and you had a negative exponent. Well, remember that a whole number, a number that's not a fraction, is actually over 1. So flipping it would turn it into 1 over that number, or in this case, 1/3. So in this case, our final answer is 16/9. So now that you know how to do exponents, those kinds of problems will hopefully be pretty quick on the test. But something like this might take a little bit longer. So let's go over how to do this. Here we have a quadratic equation, which is where you have an x squared, an x, and then just a number by itself. And we need to solve for x. So there's a bunch of different ways to solve quadratic equations, and they'll all give you the same answer. But like by far the fastest way to solve a quadratic equation, if you're able to, is factoring. And on a test like the ACT, being able to do a problem faster is always good. So let's see if we can factor this quadratic equation. The way that we do that is we need to find two numbers that add up to the number next to x and multiply to the number that's by itself. And remember that these signs are included as well. So we're adding to +2 and we're multiplying to -8. So let's go ahead and start listing numbers that multiply to 8. I'm going to ignore the negative sign for now and you'll see why. So first let's try the obvious one, which is just 1 and 8. 1 times 8 is 8. And to know which one we have to put the negative sign on, you just have to recognize that we are adding to a positive number, which means the bigger number is going to have to be the positive one, and the smaller number is going to be negative so that they could add to a positive number. So our negative sign is going to go on the 1, and -1 times 8 is -8. So we know that these multiply to -8, but if we add these together, we get -1 plus 8. That's the same thing as 8 minus 1, which is 7. And we are looking for them to add to 2, so that does not work. What about 2 times 4? 2 times 4 is 8, and we have to put the negative sign on the 2, because if we put the negative sign on the 4, then we would add to a negative number because 4 is bigger than 2. So these multiply to -8, and if we add these together, then we get 4 minus 2, which is 2. And that is the number that we're looking for, which means that our two numbers are -2 and 4. So because we were able to figure out these two numbers, that means we are able to factor, and we are going to use these two numbers in our factoring. So basically the goal of factoring is to turn this equation or quadratic equation into two sets of parentheses. And to know what numbers to put in the parentheses, we use these two numbers here. We got -2 and +4. So we're just going to put those numbers inside the parentheses. So now how do we use this to solve our quadratic equation, to solve for x? Well, you might recognize that because these do not have a sign next to each other, that means it's multiplication. So we're multiplying these two sets of parentheses together. And whenever you multiply anything by 0, then the whole thing becomes 0. And we know that this equation is equal to 0. So for example, if x minus 2 was equal to 0, it would be 0 times this, which is 0. Or if x plus 4 was 0, the whole thing would be 0. So there are two ways that this equation can be equal to 0. So we're going to split this up into x minus 2 equals 0 and x plus 4 equals 0. We can only do this because the equation is equal to 0. So now we just need to solve for x in each of these individually. So here we have x minus 2 equals 0. We need to get x by itself. So we're going to get rid of this -2. And the way that we do that is by doing the opposite of minus, which is plus, and adding 2 to both sides. So these cancel out. and we just have x equals 0 plus 2, which is 2. So 2 is one of our answers. On the other side, we need to get rid of this plus 4. So to do that, we're going to do minus 4 on both sides. So these cancel out, and we just have x equals 0 minus 4, and the 0 is not doing anything, so that's just minus 4. So minus 4 is our other answer. So we found our two answers, x is equal to 2, and x is equal to minus 4. So our third problem in this video is going to have to do with functions, which is another one of those important categories on the ACT. So we have an f of x here, and it says it's the square root of 4x minus 1. But instead of f of x, it wants us to find f of minus 2. So remember that f of x in a function is basically just the same thing as y. So you have a y and you have an x, so you could like plot this on a graph if you wanted to. But to solve a function, in this case, it wants us to find f of negative 2. You'll notice that f of negative 2 is the same thing as f of x, except we've changed x into negative 2. Which means that on this side of the equation, we need to do the same thing. We need to take x and turn it into negative 2, and then that's going to give us some number. So I'm going to rewrite this side of the equation, but instead of x, we're going to put negative 2. And we're going to put it in parentheses because if we didn't, this would say 4 minus 2. And when you have a number and a letter next to each other, that means multiplication. So we want to keep that as multiplication by putting this in parentheses. This is 4 times negative 2. So now let's just simplify what we have here. So here in this inside of the square root, we have 4 times negative 2. 4 times 2 is 8. And we have one minus sign, so the minus sign stays. And then this minus 1 here is just going to stay right here because we didn't do anything with it. And now let's continue to simplify this. So here we have negative 8 minus 1. If you're ever confused about negative numbers, just think of it as like money. So you lost $8 and then you lost another dollar, so you are down $9. So the last thing to simplify is to just figure out what the square root of negative 9 is. The only problem with that is that you can't take the square root of a negative number, because if you multiply two positive numbers together, you'll get another positive number. But if you multiply two negative numbers together, you'll still get a positive number. So you can't take the square root of a negative number. However, we can take the square root of negative numbers by using imaginary numbers. So imaginary numbers are always written with the letter I, and the letter I is equal to the square root of negative 1. So what I'm going to do is I'm going to split this up into two square roots. I'm going to split this up into the square root of negative 1, which we will turn into I later, times the square root of positive 9. Because if you multiply these together, you'll get 9 times negative 1, which is negative 9. So the square root of negative 1 is the letter I, and the square root of 9 is 3, because 3 times 3 is 9. And in algebra, we usually just put the number before the letter, so I'm going to turn this into 3i, and that's it. Our answer in this case is 3i, that is f of negative 2. So the next category that the ACT lists is geometry, but I'm going to save that one for last, and we're going to do probability. So this one is a probability word problem. It says, Gerald rolls a die twice. What is the probability that his first roll is an even number and his second roll is less than 3? So for this probability to happen, there need to be two things that both happen. So the first one is A, that he rolls an even number on his first roll, and then B is that he rolls a number less than 3 on his second roll. So let's figure out the probabilities of both of those things, and then we can figure out the probability of both of them happening. So for this, we're assuming that this is a 6-sided die, so 1 through 6. So it says, first he needs to roll an even number. What are the chances of that? Well, how many numbers on the die are even? Well, 2 is an even number, 4 is an even number, and 6 is an even number. But 1, 3, and 5 are odd numbers, so those don't count. So we have 3 different numbers that he can roll out of 6 numbers in total. So out of the 6 numbers on the die, 3 of them will make this true. So his chances are 3 out of 6. And this fraction can actually be simplified. So we have a 3 at the top and a 6 at the bottom. If we divide both the top and the bottom by 3, then that will give us 1 for 3 divided by 3 over 6 divided by 3 is 2. So 3 over 6 is the same as 1/2. So 1/2 is the probability of him rolling an even number. Now let's look at the probability of on his second roll, he rolls a number less than 3. How many numbers on the die are less than 3? Well, 1 is less than 3, and 2 is less than 3, but that's it. There are no other numbers on 1 through 6 that are less than 3. So that means he has 2 numbers that he can roll out of the 6 possibilities. So he has a 2 out of 6 shot at making event B true. And this fraction can be simplified as well. And I can see that because these are both even numbers. So that means I can divide both of them by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So his chances of rolling a number less than 3 is 1 over 3. So we know the chances of him rolling an even number, and we know the chances of him rolling a number less than 3. So how do we figure out the chances of both of them happening? Well, because these are two separate dice rolls, these are not affecting each other in any way, that means all we have to do is multiply the two fractions together. So he has a 1 in 2 chance, and then that's multiplied by a 1 in 3 chance. And remember that to multiply fractions, you multiply the tops and bottoms. So 1 times 1 is 1, and 2 times 3 is 6. So for him to roll an even number on his first roll and then roll less than 3 on his second roll, the total chances of both of those happening are 1 in 6. So here's another example, and this one is going to be geometry. And according to the ACT, this one also includes trigonometry. Now you might be saying, well, I don't know anything about trigonometry. I never took trig. I don't know anything. Well, I'm going to show you the basics of trig in about like 2 minutes. All you need to know about trig is SOHCAHTOA. Basically in trig, everything we do is about 3 different ratios. So we have sine, we have cosine, and we have tangent. And these are abbreviations. They're abbreviated sin, cos, and tan. So each of these are basically just different sides of the triangle. So for example, sine is opposite over hypotenuse. By the way, this is the angle here that we're talking about. This little symbol here means theta. It's basically just a letter that shows you that there's an angle there. So opposite is the side that's opposite of this angle. So here's the angle, and the side opposite it is 3. So 3 is our opposite. Then this side right here is actually called our adjacent side because it's the one that's right next to our angle. The angle's touching it. And then the longest side, the diagonal side, is always the hypotenuse. By the way, the other ones, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA is basically just an acronym that tells you what these are. So this says that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It's SOHCAHTOA. So in this case, it's saying that we need to find sine of theta, and theta is right here, like I said. And remember that sine is opposite over hypotenuse. So which one is the opposite? Well, opposite this angle is 3. So our opposite is going to be 3. That's going to be the top of our fraction. And then the hypotenuse is the diagonal side. It's the longest side. And the longest side is 5. So 5 is going to go at the bottom of the fraction. And that's it. The sine of this angle is 3 over 5. So I hope that being able to see one of each of those types of problems helped with your studying. But if you need even more ACT practice, then I do have 5 more example problems that you can watch in this video right here. And as always, if you have any questions about this video, go ahead and leave it in the comments, and I'll be sure to answer your question. Thanks for watching.